Hello and welcome to this Engerati interview. I'm joined now in the hot seat by Donald Pollock, who's the Senior Vice President of Sales and Marketing, is that right? At Ambient. And Donald, one of the topics I want to explore this year, which has been a conversation that's been building slowly, and I feel is now, I wouldn't say a hot topic, but it's certainly tipped its way over from a background conversation to coming in the foreground, is this whole concept of renewables, integrating renewables in the grid, how we do it, what are some of the technology challenges behind it, and what do we need a smart grid infrastructure to make it work, or can those renewable generation plants exist as islands and be tapped much like a conventional source would? What are your sort of experiences on that?
Okay, well, I guess there's two aspects to renewables. There's obviously commercial distributed generation that's seeking a connection to the grid to then be utilized as is required by downstream customers. And then there's also domestic renewables, whereby you're getting the prevalence of photovoltaics being introduced into the domestic consumer base, and the impact that can have on the low voltage distribution side of the grid. I think obviously because of where we are at with regard to the smart grid, communications is going to be key to that. And if we take the first example, whereby there's new distributed generation connections on a commercial basis to the distribution grid at whatever point, it creates a certain parameters that need to be examined and sensed and monitored to ensure that the existing infrastructure, the cables, the wires, the transformers can all cope with that introduction. Now, there will obviously be control elements that are associated with those renewables. There will be monitoring relating to the feed-in that's being made from those renewables. And you have to be able to balance the input with the distribution of that power within the grid. And you see whether it be wind and solar as the distributed generation, and then the impact that it has on the grid, or it's introducing monitoring technologies. And alongside the photovoltaics and the wind power, there is the requirement to have storage on those times when the input is more than the actual infrastructure can actually cope with. What Ambient have provided for a number of utilities is looking at being able to fulfill both the command and control of the assets by introduction of the IEC 61850 protocol, which is an intelligent endpoint device protocol that's being used, and also to communicate with line sensors that are there as well. And then, if necessary, change the pattern of distribution to ensure that it goes to storage.
So what's the, everybody's talking about the integration of renewables as an energy source being a big deal and a massive challenge.
Yeah.
But when I talk to the technology vendors, they're by and large saying, well, actually the tech's here already. Yes. So where is this challenge? I don't want to sound glib about it, but what's the big deal about integrating renewables into the grid if a lot of people are saying, well, the technology to control them is there?
The technology to control them is there. It's whether it's cost efficient to be able to exercise all that control and to ensure that all the different assets that are playing a part in that integration of renewables know their respective role.
So does it come back to economics and things like that? So let's take a hypothetical scenario. I'm running a wind farm, and I want it to be running the whole time at maximum capacity, because that is me utilizing the asset from an energy production point of view to its fullest capability. But that is probably not what my off-taker, be it the grid or some commercial entity, wants. So, where is, or are you saying that actually you could run it at full tilt the whole time if you think about the whole thing as a system, with storage and production all as one?
I think that you can potentially run it as a whole system, whereby you're linking both the distributed generation with storage assets at the same time. If you are processing that type of system, it's much simpler in effect to automate it, and to automate it out in the field, and by the use of distributed intelligence, whereby you can have different assets that are communicating their actions or data to a central processing unit.
So this is all the M2M stuff.
And you use that platform to say, okay, you can produce at this point in time, or we can shift it to storage, or we have sufficient capacity and headroom within the network at this point in time to allow it to continue to produce at will. And the systems exist, but all of those different assets that are involved within those systems require communications. And our philosophy is that why build individual single-use networks to take all the information back to a central head office when you can share the data within a node-based distributed intelligence to control the assets in a microgrid environment, or to take some of the information back to central if it's required to do that. Or you create a model that is then exercised within the grid as a consequence of the different patterns that exist from the production.
And where, one of the other conversations around the whole renewables piece and things like that is, do you think the generation of renewables is just a mindset change, and we need to just understand how this generation source works, and once we get over that hurdle, say it might take us 5 years to get our heads around it, it's going to be the next big investment area that we're going to see more and more renewables coming on grid, more and more need for what you were describing as this sort of almost artificial intelligence type data network to control all these endpoints.
So renewables are there. If you look around whichever country that you reside in, certainly where in the UK where I'm based, you can see that there's wind farms cropping up at different places within the grid. You're seeing now solar farms. I think that they are in place at this moment in time. And it's at which point does it become a problem to the existing infrastructure? Is there sufficient capacity there to handle the renewables that are being introduced? And so that they are certainly being adopted in a widespread way, but it's just that management to ensure that it doesn't cause disruption on the grid.
So do you think that renewables are the single biggest driver to either a smart grid or a sort of grid overhaul, reinvestment?
No, I don't think they're the single biggest driver at all. I mean, you know that obviously we've been talking about it for quite some period of time, but we've got the 2020 initiative, which is obviously about energy efficiency, it's about sustainability, So it's a combination of the smart metering, the distributed generation, demand response is also going to be part of that as well. It's distribution automation, so fault location, isolation, and service restoration that's involved. So you've got a combination of different applications that are all at the same time bubbling up at different degrees. I think what's very transparent with renewables and the increase of production within the distribution grid is that this can create a problem now. And therefore it has to be managed effectively. Whether the solutions that are put in now have the scalability or alternatively are as cost effective as they need to be to allow the whole renewable integration to happen at pace and in an effective manner that doesn't get the utility or the DNOs spending more money than they have to. So I think it's that pulling together the different assets within the grid in a systematic way that makes it is going to be the challenge that's involved there. But alongside renewables, there are all the other applications that are at play as well.
So let me ask you this, because obviously when you're in the market, you watch the market and you look at what's going on. I don't think the 2020 deadline was going to be met, personally. I think we've got too many conflicting forces at play, which one is the economic situation,
sure.
So, the investment and things like that, and the question you can agree or disagree with that statement.
Yeah.
But one of the other things I wanted to ask is if 2020 is the deadline.
Yep.
In every project there is another deadline. If you're going to hit 2020, certain things need to happen before that time.
Yes.
And I would argue we're pretty close to that time, which is what leads me to make the statement that I don't think 2020 is going to happen. Not to the scale it's designed. The desire is at.
Maybe the desire in terms of the scale. As regards the individual countries or the whole European operation, I think it's, I don't know sufficiently at which stage or which yardsticks or measures each of the different countries are at for the relative elements of 2020. So what we have seen as a consequence of the economic situation is, and perhaps political in some countries as well, is there's been a slide or there's been a change in focus, or there's a realization that something else needs to be addressed before we move to this. And it's a transition between smart grid and business as usual. And if we continue on a business as usual investment basis, where we're not deploying either enabling or smart grid solutions, the cost of implementing those business as usual to cope with the introduction of distributed generation or other applications that are smart grid related will be more than it needs to be. And I think it's the pulling together of all these different applications to have a uniform system, which is important, and that requires conversations between different elements within utilities to ensure that they've got the best system to move forward, whether it be communications or whether it be grid infrastructure.
And those conversations are sometimes hard to have, because we had a panel earlier where we were diving into some of the complexity about, in an ideal world, who needs to be talking to whom, and when we started going into it, I can't see that happening, and the political frameworks are over and above that as well. So we're coming to the end of our time. I'm gonna. I know you've got a background in journalism, and I'm going to take you back a little bit and set you a small challenge.
Yeah.
You're the roving reporter.
Right.
You've kind of walked around. What's a highlight? What's a
what's the highlight?
Or what's a low light?
The low light.
Where you're like, can't believe we're still talking about this. Which is a hard question to ask in a trade show because you're always talking about the same thing, kind of.
Yeah, well, what is apparent, and it relates back to what we've already said, in any disruptive technology, you have to actually win your arguments to change people's perceptions of and to change their actions of what they do. And that's the challenge, I think, is to ensure that people are prepared and to take risks, to implement new technologies, and that takes time and effort to win the arguments, to win the business cases, to ensure that we do have a smart grid in the future.
Do you think the energy industry is winning enough of those arguments quickly enough?
I think they're on a path. They're on a path.
Good. On that point, we'll leave it. Donald, pleasure as always to talk to you, and thank you again for watching. It's another Engerati interview, and many more to come. But we're off for a short break, and we hope you've enjoyed this interview series. There are a couple of more towards the end of the day, and a whole lot more over the next couple of days. Thank you for watching.